Well, hello. Greetings and welcome. This is at one, and yeah, welcome to our neighborhood. Fiddling around with different camera angles right here, just to see what works and what doesn't. I gotta put a lot of props. I never said props. Like proper respect is what That's what I think it means anyway. And shout out to all movie makers, man. It's fun, yes. The filming part is fun, but the editing is complete bullshit. Like it's almost frame by frame by frame, and there are 30 frames per second. So in an hour, there's 120, no, 1,200 frames. I've got lost upstairs. I don't know. It's a lot of frames to look at. You got to make sure that there's no wardrobe malfunctions on the thing, and everything. Editing is just, and then you got to move pieces around, and if you move something around, you might screw up something else. And sometimes it's like laying carpet, and you put one corner of full, and when you do that, it comes up to the other end, and so you go to that end and put in the carpet in the corner, and then the other, it'll, yeah, it's like a problem where that's kind of like what I'm dealing with, is a problem that don't know if there is a quick solution. By quick, I mean less than 10 pages. What I'm trying to prove is, I'm trying to prove a few things, but one of them is the doomsday theorem. And it states, I'll first state what the doomsday theorem is, or conjecture. I haven't actually proved it yet. I think it's true though. If so, then I'll look tirelessly for proof. Yeah, and so the doomsday theorem, I'll tell you what it is first, and then I'll tell you my interpretation of it. And that's why I'll tell you why I call it the doomsday theorem. It's doomed for mathematicians. And by that, I include automated theorem provers as mathematicians. I mean, if an 8-year-old could be a mathematician, then so could fucking Mathematica. It's older. It's old enough. It's what, 30 years old? Yeah. So I mean, it's a theorem prover. 1 + 1 = 2 is the simplest, like a simple example. 1 × 0 = 0. Is anyone who likes that, or like, what makes a mathematician a mathematician? In my opinion, it has nothing to do with how much you know. It's how much you want to know is what determines if you're a mathematician. If you want to know, at the grocery store, there's a conveyor belt usually, and you put your items on that, and it rolls down, and then they scan them, Should you put the expensive items first? Or perhaps you should put the cheapest items first? So, which is it? And, it's kind of an interesting, I think it's an interesting demonstration of what's called additive commutativity. That's what it's called. Additive commutativity, or just commutativity. Because commutativity also is true in multiplication. And wow, so we've covered a lot of territory, I think. The theorem, their conjecture, doomsday conjecture, is that you want to see my do? My do. For any number m that you specify, there exists a theorem. It's called lambda, such that the shortest proof of lambda is at least m plus 1. I hope I got that right. I'm the one who wrote the theorem, so that should be right. So given any number, you think a large number, like Google, which is 1 with 100 zeros, is pretty big, right? You would want to have that much money, but then in that market, that's probably not good. I mean, if someone has that much wealth, then it's going to cause economic chaos, if they just spend it all. Anyway, so what I think the next part is the interpretation. Even if you have an automated theorem prover or a human, you're going to limit yourself and the computer somehow. You're going to say, I'm going to run for 1 billion years of CPU time, or a month, or 3 days, or 10 hours. And you or it will give up after that time. You'll just decide that that theorem is too hard to prove. And that's because its shortest proof is at least m plus 1. So, the shortest proof of lambda is at least m plus 1. That means that the shortest proof is at least one step after you gave up. Oh, m is the number of steps you're willing to explore in your proof if you do a depth first search, I guess. And when I say search, theorem proving is a search. There's a what do you call it? A set of all possible states, the probabilities of each of those happening, and then you get a distribution or expectation out of that. I don't know why I mentioned that, because that doesn't seem to be relevant. So I'm trying, I'm working towards proving that, and I haven't been on my project, to move forward for a long time. I've just been, stationary for a long time. But I'm stationary on a hill, and I got my brakes on, so I can go up the hill or down the hill, and hopefully I just go up the hill. And so that's doom for mathematicians. That means there always will be a theorem that they will never be able to prove. And I think that's pretty cool. It seems like a limit, Of course, we all believe, I think, that we'll never prove everything. If you consider 2 100-digit numbers, and then the product of those two is roughly 1 Google squared, which is big. It's a big square, unless they're nanometers or angstroms or something.